I've been working on my programming stuff again, and I made some updates to my binary bitmap project. See, I have this huge collection of code, and I've spent a great deal of time on finding ways to draw polygons. And I think I just about got what I need. So I'm going to try to switch to showing my screen and show you my amazing code and what it can do. So I have a folder here where I call it BBM, stands for binary bitmap, and I have several source files in here. And I'm going to show you the current setup of my code. Let's see if I can figure out. Oh man, it's horribly disorganized here. Okay, so see, main.c, there's several header files that I include, and aside from the standard ones, all the other header files I wrote myself, and there's quite a great big deal that goes into this. So I'm going to show you, for example, the Polygon header here has several different things. It has a rounding function, it has pi, it has a function which gives me the points of a regular polygon given the different variables, the center x and y coordinates, the radius of it, the radians in rotation of it, and the number of points. And I don't call that function directly, but instead it becomes part of this function. This function is where the magic really starts happening, because all these variables have to be put in here in a very specific way. Then it calls the polyPoints function and gets those points, and then it uses the line drawing function. And that's the thing, is the line drawing function is one that it took me years to figure out, and finally I found that the answer was already in existence, the Bresenham line draw algorithm. But before I show you the line draw algorithm code, I'll show you the ScanFill algorithm. Now this is one that I wrote myself. It's not as efficient as the way it's supposed to be done for filling a polygon, but my method works. So for example, if there is an image that's black, it will scan through each line and then if it finds any colors that are different than the original background color, it keeps the location on the left and then scans on the right, finds where the right is, and then it fills in between those 2 points on that line, whatever that color is. And that's how I get filled in polygons. And then there are other functions in this file, but those are not important right now. I'm going to briefly show you my, let's see, bbmlib.h is the one that has several things. This has the line drawing algorithm. Now, the code, I don't fully understand it yet. However, there is a link explaining it that I have somewhere else. But this is the line drawing function that draws a line using pixels. It's very, very complicated. So that's what is used here. So, but it doesn't fill in the polygon. My ScanFill function does that. But all these functions in isolation do absolutely nothing. It's only when they're combined, being used in a very specific order, that anything interesting happens. So what I'm going to show you is, now you'll see the BBM Polygon Animation 0 function is called here, but that is actually defined in this file, bbm polygon animation.h here. So I'm going to open that file. See, these were all recently opened, so that's how I can open them so easily. So this is where things get very interesting. See, I just wrote this tonight, and there are 3 images, and they all have different purposes, which I kind of included in my comments here, but my comments don't do it justice, because unless you're me and you wrote the code yourself, you wouldn't understand this. But we know from this that there are 3 images, 3 different pointers to pixels, and the width is 512, and so is the height in pixels. And then these are used for XORing later, the bitwise XOR operation, and that's for the size of the squares on the checkerboard because I use a checkerboard. So there are 360 degrees in a full turn. It could be more or less, but I'm sticking with the traditional 360 angles in a full turn, like the system of degrees. And right now, I have a frame. Frame is going to be the current frame number, and frame max is the highest it goes. Currently that's set to 1 here, but later on I have a thing here where it's the full turn divided by the number of points. So I had the points be 6 for a previous animation, but for simplicity I'm going to change this to 3. So it's going to be 3 points, so it's going to be a regular triangle. And this radius here is 256. However, that's actually set later. It can be changed, obviously. And radian starts out as 0. That's the current rotation. And this color thing, I modified colors just a little bit strange. It starts out as red because, you know, the first 2 hex digits are red, the next 2 green, the next 2 blue. I have a standard for how I do it. So this calls my BBM malloc function, which is, of course, it uses malloc from the C library to allocate the right number of bytes of memory. So you don't need to worry about that. I have that in my code elsewhere, but I'm allocating memory for all 3 images. They're all the exact same size, and you'll see at the very end I free the memory for all 3 of them, P, P1, and P2. So here's how it happens. I'm trying to do my best to explain this because I uploaded a similar animation recently, and I want people to know how this works. This is very complicated and took a long time to do. So I have my chastity checker function, which I've shown in previous videos, which hasn't really changed in what it does, but it's drawing a checkerboard to P1, which is my second image that I allocated. And that one just stays a checkerboard and it doesn't change throughout this. Now frame max is the full turn divided by the number of points. So since there's 360 degrees in a full turn and it's divided by 3 points, it's going to be 120 frames. So there's going to be exactly 120 frames. That's the way it's going to work. And the repeat variable is set to 1, so we can ignore that. That's for repeating the animation when I'm creating a video file. So I'm not using that right now. So the output image is just known as P. So that one becomes black at the start of each frame. And then we set the radius to be the image height divided by 2. So in this case, 512 divided by 2 is 256, same as it was defined at the top, which is silly, of course, but I have it defined twice for some odd reason. And then while the radius is greater than 0, it does this loop. So first it takes the third image, known as P2, and it erases that image and fills it with black. Then it draws a polygon with all the variables passed. So we see that P2 is the image we're drawing to, the width and height are passed, and the width divided by 2 and the height divided by 2, that is the center X and center Y coordinates we're passing for where the center of the polygon is. In other words, we want it in the direct center of the image. And then we're passing the radius variable here, which is what this loop is all about. And radians, we're passing that as well, and the number of points. So we're passing all of these as arguments to this function. In the future, I've thought about doing a separate product where I use all global variables for this, but this allows you to have several different variables for several different polygons, although I usually only feature one. And then the color, which we defined earlier as red, is there. But here, this is where it gets interesting. So it draws that, and then it tries to use the ScanFill to fill in that particular image. Now keep in mind, during each iteration of this loop, P2 contains only one polygon, which is then filled in. But then, each time it draws that polygon and fills it in, then it XORs the P2 image with P, which is the output image. So we're basically XORing every single pixel of P2 into P, which is, I know it sounds weird, but that's what I'm doing. And then this is where the color gets modified, and I'm XORing the fill color each time with blue. And I don't know why I did that, but I did it, and the result looked beautiful. So you know what? I just went with it. And then you see the radius decreases by 16 each time. I can make this more or less if I want to. So I may try messing with it in the future. But right now it's 16. But then after it does all of that, then it takes the checkerboard and XORs every pixel with that to the output image. So the final result ends up being very strange. And then it increases the radians by 2 times pi divided by a full turn, which I forgot how I came up with that formula, but I did it months ago. And then it saves it using a 6 bits per pixel type bitmap image, which is not a real type of image, but it's kind of my own way of simulating it. But that's irrelevant. The point is it saves a bitmap image that can actually be viewed. So I'm going to actually run this code now. So here I'm in my Linux terminal. You see if I ls, I'm listing, yeah. I wonder what happens if I type list. List is not a command, but ls means list. So it shows all my different source files. Not all of these are actually used in what I'm showing you here. But I have a make file. I'll show you cat make file. And so you can see my make file here. It has several different commands here. And see, I can scroll through it. Yeah, I'm gonna enlarge that. See, I can scroll through it, and it shows the different types of things. See, I have several make commands that I can use. But what I'm going to do right now is I'm just going to type make, and it's going to create a series of images. It takes a while for it to actually run because it's doing a very intense operation, drawing tons of polygons each frame. So I have to wait a few seconds for this to, oh, and there it is. All of a sudden they all appeared. So you see if I scroll through this, we have start, and I specifically used the sprintf function in the C library to make it be exactly 8 digits for every equal frame, because that's important. So we see they're all bitmap files, and they're from 0 to 119. So now we're going to go to the actual file where the actual folder where all of these files appeared. So let's start by viewing the first one. Here we have, and here it is. This is where it gets interesting, because see, it was alternating between red and, well, technically it was alternating between red and fuchsia or magenta, because it was XORing with blue each time. But then it got complicated because I was also XORing it with the checkerboard before outputting each frame. So this is the beautiful result. But now you see, as I press right, and see, I can press right and go up in frames, and I can press left and go down in frames. But that's basically how it works. So as I go to the next frame number, it rotates to the right because I increased the radians by that fantastic formula. So that's basically what it does. Now, in case you're wondering how I make my GIF animations on this, I'll show you that as well. Basically, I will show you the make file again, except this time I will just open it in Notepad++, which is my favorite text editor. So I have a rule for GIF. And this one uses the magic command, magic convert, and it does. This is a formula I found somewhere on the internet to use the image magic tool to create a GIF animation out of a series of image files. So in this case, it's anything.bmp. So they are in the correct order because they're in numerical order, and the number of digits is the same. I have it padded with extra zeros, as you saw earlier. So all I have to do, if I want to make a GIF animation, I simply type make GIF, make GIF. Whether you call it GIF or GIF doesn't matter. The point is it works. So now you'll see a new file has appeared here at 3 minutes after the others. That was created after I ran that command. So now I'm going to double click this, and you'll see here it's a perfect spinning triangle. And it has a weird line that for some reason occasionally appears. And I don't know why that appears. I think that's just some sort of glitch that happened. That bothers me, but I don't know how to fix it. That's just a little bit mysterious. But anyway, that's basically how it's done. And there is quite a lot of code that goes into this. And I wish I had time to show you all of this, but I imagine this video is actually getting fairly long already. But that's the basics of how I do what I do. So I can make these cool spinning polygon animations, and that's basically what I wanted to show you. So I enjoy working on my programming, but it's also very time consuming, because it'll take me 1 or 2 hours to write a function like that does a specific animation, because I have to specify, okay, I want this polygon drawn to this image, and I want the radius to get smaller during each time of this loop, and then I want to copy this polygon from this image over to this other one. And I use the bitwise XOR operation a lot, because the way it combines with the checkerboard, as you saw in that animation, is so beautiful, and that's why I use it. So it inverts the colors. Wherever there's a white square in the checkerboard, it inverts the colors that were there. And I can even make checkerboards of other colors as well, but I usually stick with black and white. But then I started using freaky colors for the triangle or whatever other polygon I want to draw, and the result I really liked. So I upload them to social media when I'm happy. That's what I do when I'm happy. I work on my programming, and I do these cool, colorful animations. So yeah, that's what I like to do with my programming. And I've never been able to do anything fancy where I could actually make money with programming, because I like to stick with my own projects, doing it the way I like to do. But I'm impressed with what I can do. So anyway, this has been another little programming rant and demonstration. So I know quite a bit about computer graphics, and I can do stuff with polygons. That's about all I have to say for now. So hope somebody enjoyed this, and let me know if you have any questions about graphics programming, because I might actually be able to help you out. There's always a possibility. I know the C programming language pretty well.